Now that we've been introduced to our 6 trigonometric functions, I would like you to consider the following. A right triangle has hypotenuse 11 and opposite leg 5. Determine all 6 trigonometric ratios of the given angle. First thing I'm going to do is draw myself a picture of the given situation. Here is a right triangle. Indicate the right angle and indicate where the angle is. Now, the angle name, we're going to call it theta, but there are lots of different names that we could give it from back in section 7.1. We were told the hypotenuse is 11. We were told the opposite leg is 5. Now, opposite means across from the given angle. So I suppose that if I wanted to change things up a bit, the other way that I could have drawn this is if the angle is up here, the opposite leg is still across from it, so that would label this side as 5. The hypotenuse doesn't really move around though. So either of these pictures would be okay. Now, given that we know two sides of a right triangle, I want you to respond to the following. If I tell you that you know two sides of a right triangle, it does not matter what my next question is. The answer should be Pythagorean Theorem. So let's try it once. You now have two sides of a right triangle. What formula should you use at this point? Oh man, I really hope you just said Pythagorean Theorem because that's what we're going to use. The Pythagorean Theorem that you're probably used to seeing is a squared plus b squared is equal to c squared. To try to stay consistent with the notation that we have in the book, I'm going to call it a squared plus b squared is equal to r squared. A is referring to the adjacent leg, which we do not know. B is referring to the opposite leg, which is 5, which we do know. And finally, the hypotenuse is 11. Simplifying according to the order of operations, we'll square the 5 and square the 11 to get 25 and 121. Subtract the 25 from both sides, we get a squared is equal to 96. Normally when we take a square root of both sides, we would include a plus or minus, but because we're referring to lengths, a plus or minus is unnecessary. It will, however, be necessary for us to simplify this radical as much as possible. We factor the 96 into 16 times 6, which simplifies into 4 square roots of 6. Now, once we have that third side for our right triangles, either right here or right here, once you have all three sides of your right triangle, you can now set up your 6 trigonometric ratios. So the sine of the angle is going to be the opposite over the hypotenuse. Opposite side is 5, hypotenuse is 11, and that's all that we need to say. When you're writing down your trigonometric ratios, don't forget to indicate what the angle is. Doesn't make a lot of difference if we're only referring to one angle in the problem, but later on we're going to be looking at things that have multiple angles. For the cosine of the angle, we'll be looking for the adjacent side over the hypotenuse. Adjacent would be 4 square roots of 6, and the hypotenuse is now 11. The tangent is the ratio of the opposite over the adjacent. That would be the TOA of SOHCAHTOA. The opposite side is 5. The adjacent side is 4 square roots of 6. I would like to try to be as clear as possible. This has a radical in the denominator. Nobody cares anymore. We learned it in algebra so that we can familiarize ourselves with the technique. If you absolutely are cringing right now and must fix it, then go ahead and multiply top and bottom by the square root of 6 to get 5 square roots of 6. Divided by 4 times 6. That'll be 24. The reason that I typically would say don't bother fixing it is because if we're going to calculate the cotangent of the angle, that's the opposite, or excuse me, the reciprocal of what we just did. So flip top and bottom and you got yourself something that doesn't have an irrational denominator. Cotangent would be 4 square root of 6 over 5. Same thing goes for the secant of theta. Secant of theta is the reciprocal of the cosine. That's hypotenuse over adjacent. That'll be 11 over 4 square roots of 6. If you want to use the same technique that we just did for the tangent to simplify this, feel free to multiply top and bottom by the square root of 6 to get 11 square roots of 6 over 24. Finally, the cosecant of theta. Cosecant's a hoe. That'll be the reciprocal of the sine. That'll be 11 over 5.